Yes. Yeah. Good evening, all. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes nearly 10 plus years of experience in this big data environment. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes. So as part of today's demo, I'll be covering the following things. What is big data? Why Hadoop? Why Hadoop and Spark? So I'll discuss first Hadoop, later I'll come back to Spark. Drawbacks with the current databases. Drawbacks with the current databases, right? Yes. Hadoop advantages. Hadoop scope and job market. I'll come back to Spark. Starting with the big data. What is big data? The name itself saying like huge volumes of data. Where the data is getting, where day by day the data is increasing enormously. Where the data storage units. Should I heard about that? It should have KBs of data, MBs of data, GBs of data, or terabytes of data, exabytes of data, zettabyte, etabyte, sotabytes, so on, right? KBs, MBs, GBs, TBs, exabytes, zettabytes, etabytes, and sotabytes of data. Here, petabytes is missing. GB, TB, petabytes. You should have seen KBs, MBs, or GBs, and even TBs, right? But do you think petabytes of data is it getting generated? Petabytes of data is it getting generated? If so, examples of petabytes of data generation. Today, most of the applications generating data in petabytes. If you talk about a banking sector, if you take example of a banking sector, right? Within a city, you can see hundreds of branches for the particular. For example, if you take a banking like SBI, so within the city, you can see hundreds of branches for it. Within the entire state, lakhs of branches, thousands of branches. Within the entire country, lakhs of branches. Again, in each branch, millions of customers. Each customer making multiple transactions per hour, per day, per week, per month, and year, right? Each and every transaction has to be stored. You can see huge data is getting generated, right? Huge data is getting generated, right? Okay. Forget about this. You are aware about social media like Facebook, right? Facebook. In a minute, what is the data generated by Facebook, right? Millions and trillions of users for Facebook, not only within the country, entire world. It has got users throughout the world, right? How many posts and videos are getting circulated? What should be the storage capacity to store all the videos and posts? Right. Not only Facebook, right? Today, many applications generating in petabytes. Examples of petabytes of data generation. If you take just 1 minute a transaction, if you just take 1 minute transaction, how many Facebook posts? How many Twitter tweets? A minute, how many Twitter tweets, right? Google queries. Today, everyone querying in the Google. What is the data generated by Google in a minute? And if you talk about YouTube videos upload, what should be the storage capacity to store all the videos, right? email or Gmail messages. What should be the storage capacity to store all the messages? Just now I was talking about the bank transactions, telecom transactions, right? And e-commerce transactions like Flipkart, Amazon, all this, right? So everywhere we see like huge data is getting generated. Petabytes of data is getting generated, right? Yes. Currently we have got databases. Currently we have got databases like Oracle, MySQL databases, Oracle database, MySQL database, SQL Server, DB2. All these they are used for OLTP, online transactional processing. These are used for OLTP, online transactional processing for day-to-day operations, right? For day-to-day operations. You've got some specialized databases. Specialized databases used for data warehouse like Teradata or Netezza, Vertica. These are used for data warehouse. OLAP, analytical processing. They are for analytical processing, right? Yes. Okay. But today, these databases, specialized databases, they can handle data up to some extent, but beyond that, they cannot, right? So as a solution to all the storage level problems, right? And also processing that huge data in quick time, right? So we have got a framework called Hadoop. Before I go with the Hadoop, you need to see how the data is getting generated from the last 50 years. This is the data which has been generated from the last 50 years. From 1973 to 2020, 1974 to 2024. See, 1974 to 2014, compare the last 10 years data. Compare the last 10 years data with the previous 40 years data, right? So only 20% of the data has been generated from the previous 40 years, but 80% of the data what we see currently has been generated from the last 10 years. Reasons for huge data generation, especially in the last 10 years, because of usage of smartphones, usage of smartphones, usage of internet. And whatever this 80% of the data has been generated is from where this data is getting generated. Mainly from where this data is getting generated. Mainly we have got three sources of data. We have got three sources of data. Social data, data which has been generated from the social websites, social sites, right? Machine data, data which has been generated by reading or scanning the barcodes, RFID chips, right? Such kind of data we call it as machine data. And transactional data. social data, machine data, and transactional data. Transactional data like day-to-day transaction like bank transactions, telecom transactions, right? These are the mainly three sources of the data. And the types of data mainly going to occupy three forms, three types of data. Three types, right? Structured data, semi-structured data, unstructured data. Structured data, semi-structured data, unstructured data. Structured data, which is organized in the form of rows and columns in a structured format, right? Like Excel tables, Excel files, DB tables, right? Semi-structured, which is not fully structured, which is not fully unstructured, like XML files, JSON files. Unstructured, like chart messages, articles, images, videos, all this comes as unstructured. The biggest challenge today is to handle this unstructured data, storing and processing this unstructured data, right? Okay. So as a solution to all the storage level problems and processing level problems, right? We have got a framework called Hadoop. Hadoop is a framework. It is going to perform two things. It is going to perform both storage and processing. It performs both storage and processing. Talk about any technology, it either performs storage or processing. Talk about C or C++ or Java, .NET, all this, they're meant for processing. Talk about these databases like Oracle, MySQL, DB2, all this, right? They're meant for storage. But Hadoop is meant for both storing and processing. For storage, does the Hadoop use any database for storing its data? No. The databases has got some drawbacks. Despite of these drawbacks, still Hadoop doesn't go with any database for storing its data. It is going with a kind of file system called Hadoop distributed file system. I list out the drawbacks of databases. So despite of the drawback to the databases, it is going with the file system called Hadoop distributed file system. And for processing, we are using a execution model called as MapReduce Spark. Currently going with Spark. So both for storing and processing. For storing, HDFS; for processing, MapReduce or Spark. And understood that Hadoop is meant for two things: storing and processing. For storage, HDFS; and for processing, MapReduce. Drawbacks: why databases can't be used for storing Hadoop's data? Drawbacks with the current databases. Drawbacks with the current databases. First thing, less storage. Most of the databases, very less storage. No parallel processing in most of the databases. No parallel processing. And see this, if volume increases, volume of the table, if volume increases, speed decreases, right? If volume increases, speed decreases. Speed decreases. Example, if I take a query like this, select a total amount, from sales one table, just got 10 records. It has got a 10 records. Select the total amount. Select the total amount from sales to 10 lakh records. Select the total amount from sales 3, which has got 1 crore records. Total amount from sales 1, total amount from sales 2, total amount from sales 3. Sales 1 10 records, sales 2 10 lakh records, sales 3 1 crore records. Okay, or 10 crore records. Now try to answer which query is going to execute faster among all these 3. Yes, try to respond. Which query executes faster among these 3? Total amount from sales 1, that is 10 records. Total amount from sales to 10 lakh or 10 crore.
First
The
query.
first query executes faster, right? Sum of total amount from sales 1 of 10 records. So here query to query is volume increasing, speed decreases here. Even if complexity increases, speed decreases. Even if complexity increases, speed decreases, I'm saying. Even if complexity increases, speed decreases. Complexity increasing, speed decreases. For example, same total amount from sales 1, total amount from sales 1. I'm taking a query like this. Total amount from sales 1, which has got 10 lakh records. Select for example, average amount. Average amount. Same thing, 10 lakh records. Select standard deviation. Select the standard deviation of amount from sales 1. Yes, okay. Same 10 lakh records. Total amount from sales 1, 10 lakh records. Average amount from sales 1. Standard deviation of amount from sales 1. 10 lakh records, right? Which query execute faster among these 3? Same table. See, this average amount is a 2-step process. First, sum has to be calculated. Next, average to be calculated. Takes more time as compared with the first query. This third query, lot of internal processing requires for standard deviation. Means here also the first query execute faster. Query to query. Here also complexity increasing, speed decreases. And the major drawback with the databases. Databases, right, can handle only structured data. Can handle only the structured data. Can handle only the structured data. For example, Cannot handle unstructured or semi-structured data. For example, I want to take reviews for a particular movie. Reviews is the table. User providing reviews, review. Yes. User 1, user 2, user 3. In this way, 100 users giving the feedback. Here, if the movie is good, saying 1. If the movie is bad, saying 0. If the movie is good, 1. The movie is bad, saying 0. Giving feedbacks in the form of zeros and ones. Giving feedbacks in the form of 0. Can you count the total number of ones here? Total number of zeros here. Can you write an SQL query to count the number of ones and zeros here? Single grouping, single aggregation, right? Select review wise. I want review wise count. I want review wise count start from that reviews table. From the reviews table, group by review, output, right? Review wise. So how many ones, how many zeros? 90 people saying the movie good, 10 people saying the movie bad. So here we can write, but reviews won't be given in the form of zeros and ones. Right? They'll provide in their own text format. First person saying movie is good. Second person saying movie is not good. So in this way, they'll provide data in their own text format. Now, can you write an SQL query to count the number of goods and not goods here? This kind of data can't be handled, right? Even if you try to find by using the keyword good, it gives wrong computation because not good has got good in it. So these are the major drawbacks of this databases. Less storage databases, no parallel processing in most of the databases. If volume increasing, speed decreases. And if complexity increasing, speed decreases. And databases can handle only the structured data, right? You see the advantages, Hadoop advantages, right? Hadoop advantages. First thing, Hadoop advantages. Unlimited data storage. Unlimited data storage is possible. Secondly, very high speed processing. Very high speed processing because of parallel processing. Unlimited data storage, very high speed processing. Yes. Yes. Can handle all varieties of data. Now, can you say can handle all varieties of data? Can handle all varieties of data. Open source, no licensing required. Fast commodity hardware. Doesn't mean commodity hardware means it doesn't mean that you need to have highly configured systems. Commodity hardware, right? Any hardware, right? It can run on any systems. So unlimited data storage, very high speed processing, can handle all varieties of data. Yes. So these are the Hadoop advantages, main advantages of Hadoop practice. In the case of databases, in the case of they can handle only structured data, but Hadoop can handle all varieties of data. Now coming to this, okay, Spark, Apache Spark, right? Yes. What is Apache Spark? And before I go with Apache Spark, right, motivation to this Hadoop, 1 second. Hadoop is proven in the market storage point of view and processing point of view, right? So Yahoo has conducted a test. Yahoo has conducted a test to check the speed of different databases. Yahoo has taken a table of 100 TB consisting of 1024 columns. The task was sorting based on 16 columns, not on a single column, 16 columns. Time taken. Time taken by different databases, right? First one. Okay. Oracle has taken nearly 3.5 days to process this. MySQL, nearly it has taken 6 days to process. It has taken 6 days to process. Teradata, a specialized database used for data warehouse, right? Teradata. It has just taken 4.5 hours. Netija, another specialized database which has taken just 3 hours. Finally, Hadoop. Finally, Hadoop, right? It has just taken 3.4 minutes. The other databases which have used days of time, hours of time, where Hadoop has used just minutes of time. So Hadoop is proven in the market, processing point of view, even storage point of view with unlimited data storage. Say like what is, just I'll take 10-15 minutes on this Spark. What is Apache Spark? Why PySpark? Need for PySpark. PySpark, real life usage of PySpark. Job market of PySpark, right? What is Apache Spark? Why PySpark? Need for PySpark. Real life usage of PySpark. Job market of PySpark. Yes. Yes. Spark, right? Apache Spark. What is Apache Spark? It is an open source distributed cluster computing framework introduced by Apache Software Foundation. It is a general engine for big data analysis, for processing and computation. Why PySpark? It is a Python API for using Spark. Spark is an open source cluster computing, right, used for big data solution. PySpark is one of the lightning fast technology that is designed for fast computation. PySpark is the very demanding tool among the data engineers to work with bigger data sets. This PySpark is used for distributed SQL, for distributed SQL, creating data pipelines, ingesting data, ingesting data into database, ingesting data into database, running ML algorithms, working with graph or data streams, working with working with graphs and data streams. So why PySpark means for distributed SQL and for creating data pipelines, for ingesting data into database, for running ML algorithms, working with graphs and DS streams, right? What is the need for PySpark means? If you see large amount of data is generating through online and through offline, right? So this data contains hidden patterns, unknown corrections, market trends, customer preferences, and other useful information, right? It is necessary to extract valuable information from this raw data. We require a efficient tool. We require a efficient tool to perform different types of operations in the big data. So the various tools to perform these multiple tasks, right? So we already got many other tools available. I'm not saying that we have got many other tools available, but the tools are not so appealing and not used for this huge data. So we require some flexible tools to crack this big data and gaining the benefit from this. So PySpark is such a kind, right? Yes. So combining Python and Spark will be the very efficient way for the world of big data, right? That's why Apache Spark community came up with a tool called PySpark. Apache Spark community came up with a tool called PySpark. Python API for using the Spark. So even for the real life usages, right? It is mostly used in this commercial sector. Apache Spark real-time processing. Banks and financial fields, they use Spark for retrieving customer social media profiles to gain useful insights, which help you in taking the right decisions and create risk assessments. Spark is going to be an important role in fraud detections, machine learning tasks in healthcare, in analyzing the patient's records, also identifying the patient which is going to face the issue. Entertainment industry, the popular OTT platform like Netflix uses Apache Spark for real-time processing. It's going to process nearly 450 billion events per day that are streamed over server-side applications, even for trading, for e-commerce, Like websites, if you see the e-commerce sites like Flipkart, Amazon, all this, they use Apache Spark for advertising, for recommendations, enhance customer experience, and optimizes the overall performance. And even for the tourism industry, Spark provides advice to millions of travelers. Right? So even today, like if you see that PySpark has got a huge demand today, the salary package also will be too huge, means 1.5 times as compared with other technologies. Same way, you need to have the technical skills, right? So as part of the course, what I'm going to discuss, right? See this course content, right? Yes. Big data Hadoop. What is Hadoop? What is big data? The advantage of Hadoop, Hadoop ecosystem, HDFS, Hadoop distributed file system, map reduce one parallel execution model, Scoop for import operations, importing and export operations, SQL plus Hadoop. Introduction to Scoop, Scoop import, Scoop export, importing data from databases to HDFS, from databases to Hive, from HBase to our DBMS. So how to import the data and performing different operations, transformations, merging, grouping, all this before importing data to Hadoop environment, and also exporting data from Hadoop to databases, Yarn, yet another resource negotiator. What are the different Yarn components in NoSQL database? As a Hadoop developer, you need to have the knowledge about at least one NoSQL database. So what are the different types of NoSQL and HBase, one of the NoSQL database, Hadoop database, right? How to perform various CRUD operations, Hive, Hive architecture, Hive metastore, Hive query language, loading data, inner tables, external tables, working with structured, unstructured, working with XML data, JSON data, URL weblog data. So working with joins, inserting into local files, UDF, user-defined functions, user-defined aggregate functions, tabular functions, partition tables, static partitioning, dynamic partitioning, multi-column partitioning, performance tuning mechanism, indexing, bucketing, partitioning, bucketing, and indexing. I have examples, I have an HBase integration. Now coming to the PySpark, lot of discussion on this PySpark. Major discussion will be on PySpark, right? Spark, PySpark context, PySpark session, PySpark repartition, broadcast variables, accumulators, RTDs operations, RTD computations, persistence options, PySpark core computing, groupings, aggregations, various actions and transformations, PySpark SQL data frame API, data frame data, PySpark row class, column class, select, collect with column remain, union all, map, flat map for each pivot and pivot, PySpark SQL functions, aggregate to window, date and timestamp, JSON functions, built-in functions when expr, lit, split, different inbuilt functions of PySpark. Many functions are there. No need to write huge codings. PySpark external sources working with SQL statements, Hive integration, PySpark MySQL integration, working with CSV, working with JSON, narrow and wide transformations, handling nulls, writing data back to external sources, deployment modes, local mode, cluster mode, PySpark application, states and tasks, drivers and executors, building Spark applications, deploying Spark applications to cluster and tuning, performance tuning, PySpark streaming concepts, integration with Kafka, PySpark MLlib, right? Apart from that, it's Python will be covered in brief. Python basics, people who doesn't have knowledge on this Python, right? Python basics, Python operations, operators, IDs, flow control statements, loopings, strings, collections, lists, tuples, sets, dictionary, functions in Python, modules in Python, packages in Python, errors and exceptions, file handling, object-oriented programming concepts, regular expressions, Python date and time module, operating system module, and advanced concepts like iterator, generator, closures, decorators, web scraping, working with CSV, XML, JSON files, and GUI program, graphic programming, working with Excel workbook, data analytics, pandas, numpy, and matplotlib, introduction to data science, pandas model in brief, numpy model in brief, numpy numerical Python, and the matplotlib plottings and visualizations, generating different types of graphs, normal graph, bar graphs, histogram, scatter plots, stack plots. So this is the entire Python, right? Python core and advanced both is going to be covered. So this is we are going to discuss. So it's a big data package available, right? Which includes Hadoop, PySpark, Linux. What are the Python? Nearly like 2 months. This Python sessions will be there. So by the time we are updating with Python and Hadoop will be going parallelly. Okay. So these four things are going to be covered when Hadoop is discussed. Python will be going parallelly. This will be, you can attend any of my Python batch, either morning or evening batches available for this Python. This Hadoop, PySpark, and Linux, these are weekend batches only on Saturday and Sunday. Only on Saturday and Sunday. Nearly like it goes for 12 weekends. 12 weekends we are going to discuss in brief. So on Saturdays and Sundays, right? 2 hours on Saturday and 2 hours on Sunday for nearly 12 weekends, nearly 3 months we will go. In brief, in depth will be discussed, especially for much focus will be on PySpark. Tomorrow also everyone can attend the session to see more discussion on this. Same time at 6:30 using the same link. Tomorrow you people can join, right? Any queries from your side, anyone, right? Okay. So tomorrow, so in brief, in depth, we'll be discussing about these things, PySpark, Hadoop, Linux, and Python. So we'll be getting great comment on this. Fine. So if I'm done with the queries, if there are no other queries, I will meet you tomorrow, same time at 6:30 using the same link. And from tomorrow, it will be continuation of what we have discussed. Continuation, but it's not replication of file. So I'm stopping for now. We'll continue the tomorrow session. Right. Thank you all for your time. Thank you.